Assalamualaikum. My name is Muhammad bin AMRI, and my supervisor name is Dr. Sohaila binti Sari, and my title is Development of Aquaponic Monitoring System with GUI Display. So right now, we have the context, introduction, problem statement, aim and objective, scope of project, project significance and contribution, methodology, expected result, and preliminary result. So the introduction. So the aquaponic is the growth of plants and aquatic animals in recirculating environments. Aquaponic is a phrase that combines the terms of aquaculture and hydroponics to describe partnership between plant and fish. Aquaponic systems are available in variety of sizes, ranging from tiny interior units to huge commercial units. So basically, aquaponic is where relationship between fish and plants. So the fish secretes the ammonia, which then breaks the nitrates and then goes to the plant. Plants absorb the nitrates and provides the fresh water or clean water to the fish. So right now is the problem statement. So ammonia levels are unbalanced, which makes the water more acidic. The temperature of the water could affect the suitable habitat for the aquatic animals. The consumption of oxygen in the water also increased due to the fish behavior and activity in the water. The water levels need to be monitored. This is due to the aquaponic level circulation as well as the water intakes from the plants. So aim and objective for this project: to develop aquaponic monitor system prototype for fish and plants by using temperature, water level, pH and oxygen sensor. And then we're going to develop a GUI, a monitoring system for a proposed aquaponic system, and to analyze the performance for the developed system in the plants of plant growth and feeding conversion ratio, which is the FCR of the fish. So the scope: the project is designed to mainly producing 5 red tilapia fish and 20 small medium-sized pak choy. So I'm using the reference 13 from my proposal, where from 1 to 20 ratio from that size to this size, and then create small scale prototype aquaponic system, which is 14850 cm times 1850 cm, which replicates the 120 scale of the actual fish tank in the aquaponic system in the industry. So this one I'm actually refer to the reference 13 in the proposal. For the small scale of plants, it is 6.10 cm times to 12 cm, with the height more than 6 cm to provide more oxygen in the water. The project uses 4 sensors, which is the pH, the oxygen sensor, the temperature sensor, and the water level sensor. And then the fish tank is using the plastic materials, and it is not suitable for any salt type fish enclosure. The project will be used Arduino as the microcontroller and the GUI display, and the project will be tested on Proteus 8 professional software. So the methodology: the development of the project is divided into 5 parts: literature, review, understanding the problem, develop and producing program by Arduino software, and producing and testing the hardware of the aquaponic and analyzing the record of data in the project. So this is the general flowchart for the development of the aquaponic project. Okay, next is the flowchart. The project uses 4 sensors, which is the pH to monitor ammonia level, water levels, and then the water levels to know the minimum and the maximum requirements of the water needed. Oxygen concentration is to monitor the fish oxygen consumption rate and the temperature of the water, so that it can control the behavior of the fish via active and inactive behavior of the fish. So this is the block diagram of the project. As you can see, we are using the ESP8226 for the IoT. So this is the flowchart of the aquaponic system. And then right now I'm going to explain about the flowchart. So it is important to maintain the pH levels acceptable by both fish and plants. Tilapia, for example, it requires pH to be range of 5 to 10 pH, and plants the pH level is actually best below 6.5. So as you can see, I'm referring to the flowchart. So the water levels, we can program it whether we want it or not. So the temperature reading is important to stay between 50 and 30 Celsius, and the oxygen levels need to be higher than 0.8 mg in order to cultivate 5 red tilapias in the water. Expected result: at the end of this project, the expected result are as follows. An aquaponic monitoring system prototype for the fish and plants by using temperature, water level, pH, and oxygen sensor is expected to be developed. The GUI monitoring system is for proposed aquaponic system is expected to be developed. The analysis of the performance of the developed system in terms of plant growth and the feed conversion ratio (FCR) ratio of the fish is expected to be performed. Programming and code development. So this is the item that I have purchased, which is the ORP, or known as the oxygen sensor. This is the program coding for the oxygen sensor, which I've done. This is the pH sensor. That's the box that I buy from the, if I'm not mistaken, AliExpress. This is the coding for development of the pH sensor. This is the temperature sensor, which is a DBS 1850, and this is the coding. So right now, this is the functionality of the sensor. As you can see, the pH sensor, we have the 0.84. So the water is really acidic. So we have tested that. And this is the serial monitor of the pH value. So as you can see, the readings, I have changed the water to normal water, normal tap water. This is the temperature sensor. As you can see, the serial monitor shows the reading of the temperature sensor. So this is the oxygen sensor, and then as you can see, the ORP shows the amount of values of ORP, which is in, I believe is in MIDI, yeah, ORP. So the higher of the ORP value, the more oxygen density inside the water. So the future plans, so as you can see, the study actual and current method smart aquaponic system is actually 80% in progress. The report is 70, and studying and understanding the way of the implement the smart aquaponic system to the local aquaponic system is 80%, and installing Arduino application is 100%. I have already done the codings and simulate the coding as well. So designing the GUI system monitoring system is 5%, develop the system 10%. Evaluating the development of the aquaponic monitoring system by comparing and collecting data from previous projects 5%, and PSM2 report is 40%. So as you can see, the project is not finished yet. It's nearly finished. Before PSM2 is going to be finished, inshallah. Okay, thank you very much.